In the name of Allah, the most gracious, the most merciful, praise be to Allah and peace and blessings be upon the messenger of Allah, our master Muhammad, and upon his family and all his companions. Now, after finishing the general discussion in the first episode and talking about topic in the second episode, we start with you a new episode, a new challenge, and practical information that will benefit you in the job market about the second CT test, the winding resistance test, is defined by European standards as the resistance from DC current flow at 75 degrees C. The test involves injecting DC current into the CT secondary winding and measuring the voltage across its terminals. Using Ohm's law, the winding resistance is calculated by dividing the measured voltage, VDC, by the current, IDC, from the ammeter. The resistance is then adjusted from the site temperature to 75 degrees for comparison with the factory report. Site temperature is measured using a thermocouple connected to a fluke multimeter. Voltmeter on the device that was measured through. Then we convert the measured resistance value from the site temperature at the time of the test to a temperature of 75 degrees Celsius using this equation, so we can compare it with the factory test report to ensure its accuracy. Now, someone might ask how to measure the site temperature in the first place. The site temperature at the time of the test is measured using the thermocouple that comes with the fluke multimeter. You will connect it to the fluke multimeter, switch the meter to the millivolt setting where you will see a thermometer icon, then press the black button, and we are now continuously comparing the readings. To switch between Fahrenheit and Celsius, we will press the black button and see that. Move the meter to the millivolt segment where you see the thermometer image, management, then press the black switch, and now we are comparing the feed continuously. To decide between Fahrenheit and centigrade, we'll press the black key and see. Let's assume the factory test report is unavailable. How to ensure the winding resistance value is correct or incorrect? There's a scientific method stating, if the secondary rated current is 1 amp, the winding resistance value must exceed 1 ohm. However, if the secondary rated current is 5 amp, the allowed winding resistance value must be under 1 ohm. What's the problem if we skip it? The RCT is crucial to calculate the burden on the current transformer, part of the circuit. Excluding it in test adds excess load, risking CT saturation. The third test, CT ratio test. First, IR test. Second, winding resistance test. Third, CT ratio test. What's the problem if we don't measure it? The RCT is very important for calculating the burden on the current transformer, and it's part of the circuit. If it's not included in the burden test, then loads exceeding the CT's capacity will be added, making it seem like there's an overburden, which could cause the CT to reach the saturation point faster. As for the third test, it's the CT ratio test. The first test was the IR test, and the second was the winding resistance test, while the third is the CT ratio test. The principle of this test is that we inject current on the primary side of the CT and measure the current generated on the secondary side. Then we calculate the transformation ratio, which equals the CT primary current divided by the CT secondary current, and we compare it with the transformation ratio found on the nameplate. After that, we calculate the error ratio between them. For injection, the CPC's high current output is connected to the primary terminals. Through the distinction, it is differentiated through the second distinction. CPC's high current output connected to primary terminals. CPC's high current output connected to primary terminals. And through the distinction, it is differentiated through the second distinction. If the user wants to open the second distinction, it can also be done using the second distinction switch. In seconds, the CPC shows the second distinction, and the second distinction between the second, and the second distinction, and the second distinction, and the second distinction. Between primary and secondary current, and verifies the CT's polarity. The pressure on the CT can be determined at the phase level, and it can also be defined with different design challenges. The ratio test is very important and must be ensured to be correct, because if this CT is used in differential protection, for example, as soon as the line is energized, this relay will trip instantly if there is a difference in the CT ratio between the local CT and the remote end CT.
The fourth test is the CT polarity test, and this test is considered one of the most important CT tests. I can confidently say that dozens of failures have occurred in stations just because of incorrect CT polarity. In this test, the direction of current flow in the CT is examined, and a simple rule can be applied. If the current enters from P1, it should exit from S1. The importance of this test lies in directional protection, differential protection, and restricted air fault. Any mistake in the CT polarity makes the relay see an internal fault as if it were external, and an external fault as if it were internal. This is very dangerous. The problem here is not with the relay, of course, nor with the CT, but rather in the connections between the CT and the relay. A single fault can lead to a malfunction in the protection system. Our planning can lead to a flawed protection system. There can be many incorrect reasons. Maybe the CT was designed incorrectly. Maybe CT was designed incorrectly. Maybe the CT was designed incorrectly. Maybe CT was designed incorrectly. Maybe CT was designed incorrectly. Maybe the CT was designed incorrectly. Maybe the CT was designed incorrectly. Maybe the CT was designed incorrectly. The functions in the relay meter or moving house may be incorrect. If a line is energized and polarity is reversed at one end, a fault occurs due to current imbalance. If entering current is at 0 degrees, exiting should be at 180 degrees. Reversing polarity makes both 0 degrees, activating differential protection. Ensure stability before energizing lines, transformers, or bus bars, verified through a stability test. This test simulates internal and external voltages. The relay should operate with internal voltage, not external. Engineers must check protection independence during normal operation to avoid messaging issues. The current entering is at 0 degrees and exiting at 0 degrees. The relay adds the values instead of subtracting, activating differential protection. Ensuring stability before energizing is crucial. Stability is checked via the stability test. The stability test simulates internal and external voltage. The relay should operate under internal voltage only. We will discuss stability tests independently. Engineers check if protection is independent during operation. If issues arise, it may not show a proper message. Control has managed this experiment. Where the client should work in the internal voltage and should not work in the external voltage, and we will talk about the stability tests in detail for the line and the transformer, and even the broadcast independently for the rest of the life. First, look at the genes to see if the protection is independent during normal work. Florian drives a group of projects does not show a method message. The control has managed this experiment. Now Florian has designed it incorrectly. Since the error occurred in one of the zones, it remained outside the control protection zone. There are no protective zones. The control remains straight. After that, Florian sends through busbar 2. Because the dynamic design doesn't go beyond the different designs of cars at the moment, Florian continues. That's why we need to change the control and completely replace the bus bar while setting the timing. This shows that changing the layout works. The method of testing is very simple. We connect a 6-volt battery, for example, to the primary side through a push button. We place the positive terminal on B1 and the negative terminal of the battery on B2. A voltmeter is placed on the secondary side with the positive terminal on S1 and the negative terminal on S2, S1 and on the side. With this connection, when you press the push button, the voltmeter's needle on the secondary side should move to the positive side or show a positive value if it's a digital voltmeter to ensure that the polarity is correct. If the needle moves to the negative side or the digital voltmeter shows a negative value, that means the city polarity is reversed. So that means the polarity is reversed. Inspiring the revival of a nation,